Dear students, myself Amit Patel, Assistant Professor, SMC College of Dairy Science, Anand. I am one of the content writer for the paper number 7, that is Technology of Milk and Milk Products. Today we are going to discuss module number 33, that is Technology of Dairy Byproducts 2, in which we are going to discuss whey protein products. Whey is a largest dairy byproduct and which can be converted into various value added whey products such as condensed whey. It could be of two types, plain condensed whey and sweetened condensed whey. Other product which can be manufactured from whey is whey protein concentrate, which can be manufactured by various methods, and ultrafiltration process is very widely used throughout the world for manufacture of whey protein concentrates. By far the single largest use of whey solids on global basis is in the form of whole dry whey, and it continues to grow. Whey is a dilute, highly perishable and largest byproduct of dairy world from the manufacture of cheese, casein, chena, paneer, chakka and co-precipitates. In view of the low solids content of whey, there has been a gross lack of interest in its utilization compared to other fluid byproducts of dairy industry due to the presence of high organic matter, that is 6 to 7% total solids in whey, in form of protein, lactose, fat, minerals and water soluble vitamins. Its disposal causes environmental pollution. Hence, it is very important to use this byproduct and convert it into value added dairy products such as whey powder or whey protein concentrates. Let us see some of the composition of different types of whey. Chemical composition and acidity of whey varies depending upon the source such as cheese, casein, chena, paneer, chakka and co-precipitates whey. In the table we can see the total solids of different types of whey, that is cheddar cheese whey, acid casein whey, rennet casein whey, chena and paneer whey and co-precipitates whey vary from 6.2 to 7%. The fat percentage varies from 0.1 to 0.3% for different types of whey. The protein content varies from 0.3 to 1%. Lactose content vary from 4.9 to 5.1%. Ash content varies from 0.5 to 0.7%, whereas acidity varies depending upon source of whey. Like for cheddar cheese whey, rennet whey casein, the acidity is low, that is 0.2% lactic acid, whereas in case of acid casein and chana and paneer whey, the acidity is high, that is 0.4% lactic acid, because during its manufacturing acid is used. It in general contains, that is whey contains about half of the total solids of milk and is a source of precious nutrients like lactose, whey proteins, minerals and vitamins. Whey proteins, though present in small quantity, have high protein efficiency ratio of 3.6, biological value of 104 and net protein utilization 95%, and they are next only to egg protein in terms of nutritive value. Utilization of whey. Utilization of whey has been of great concern in the dairy industries engaged in manufacturing of cheese and coagulated milk products such as chana and paneer. The techno-economic problems associated with the utilization of whey have been receiving considerable attention, and remarkable advancements have been made in utilization of different types of whey in India as well as other countries. Manufacturing of condensed whey. Whey concentration is carried out for manufacture of condensed whey with the following objectives. The first objective is volume reduction for transportation to other processing facilities. The second objective is pre-concentration for drying into whey powder, and third objective is manufacture of different types of condensed whey, that is plain condensed whey or sweet condensed whey. Various steps involved in manufacture of condensed whey are clarification, separation and pasteurization, concentration, then lactose crystallization and spray drying. Now let us start with clarification. The whey always has curd fines in it, which confer serious risk of blocking heat exchangers, channel or fouling ultrafiltration or reverse osmosis membranes. These curd fines also adversely affect the solubility properties and flavor of end product. These curd fines are usually removed by a combination of settling, screening and clarification. Next step in manufacture of condensed whey is separation and pasteurization. In order to obtain flavor stability in concentrated whey, the whey is separated to remove fat. The whey is then pasteurized for optimum microbial quality to inactivate rennet enzyme if it is cheddar cheese whey and storage stability, and it is then stored at 5 degrees Celsius till concentration and drying. Next step is concentration. The whey may be concentrated economically with the integration of reverse osmosis for pre-concentration and then multi-effect evaporator. The long tube falling film evaporators used for this purpose are characterized by short residence time, that is 5 to 30 seconds, high heat transfer coefficients and efficient energy use. Now let us discuss manufacturing of plain condensed whey. The desirable degree of concentration of plain whey is 35 to 50% total solids. Whey condensed to higher solid content, that is more than 55% total solids, forms a gel after cooling and is not recommended to be used in any food or feed products due to its coarser texture and low solubility. Plain condensed whey is also made as an intermediate product for whey powder making. The whey is concentrated and pre-crystallized before drying. The next condensed whey product is sweetened condensed whey. For its preparation, sweet cheese whey is mixed with sugar equal to the weight of solids in whey, that is about 6.7 kg sugar for 100 kg of whey. The mixture is concentrated using multi-stage evaporators to at least 76% total solids. The specific gravity of sweetened condensed whey at 50 degrees Celsius is 1.360, that is equivalent to 38.4 degree Bombay reading. The concentrate is always cooled to 30 degrees Celsius using flash coolers and served with lactose crystals. The seeds mixture is stirred for 1 hour to 3 hours to crystallize the lactose. It may then be packed in barrels or cans. The product does not require any refrigeration for storage. Now let us discuss lactose crystallization. To avoid the very undesirable caking properties of ordinary whey powder, it is of great industrial importance to get the major part of lactose content in crystalline form. The advantage of this lies both in energy savings and in improved powder properties. In the spray dryer, it is possible to dry whey concentrate containing up to around 60% total solids, when the lactose content has been subjected to a crystallization degree of 85 to 90%. On the other hand, for non-crystallized concentrate, it is not possible to attain more than 42 to 45% total solids for drying. Obviously, this low degree of concentration has negative effect on the process economics. Controlled crystallization can be initiated by immediate flash cooling of condensed whey after evaporation to 30 degrees Celsius. As far as possible, slow agitation should start immediately. Fine grained alpha lactose monohydrate at level of about 1 kg per ton of concentrate should be added. The holding time under these conditions should be 3 to 4 hours. Cooling of the concentrate should then start, the rate being about 3 degrees Celsius per hour until it is chilled to 10 degrees Celsius. The final step in processing of condensed whey is spray drying. Recent trend in drying of milk and milk product is extensively used as spray dryer. That may be single stage, 2 stage and more recently 3 stage drying. The next important whey protein product is whey protein concentrate. There has been a continuous increase in the production of whey protein concentrate since the introduction of latest ultrafiltration process. It is now a major means of whey protein concentrate production throughout most of the dairy countries of the world. Presently, whey protein concentrate constitute a very small proportion, that is 10% of protein utilization in food industry. The largest potential use of whey protein concentrate is as a replacement for non-fat dry milk, that is skim milk powder in the food industry. Whey protein concentrate with 35% protein is perceived to be a universal substitute for non-fat dry milk because of similarity in gross composition and its dairy character. Superiority of whey protein concentrate over non-fat dry milk is also due to cost advantage. Dear students, whey protein concentrate is nowadays widely used byproduct in dairy as well as food industry. It can be manufactured by various methods such as ultrafiltration method, adsorption method, precipitation method, then complexing method, gel filtration method. After concentration of whey, it is spray dried and converted into whey protein concentrate powder. Now let us highlight manufacture of whey protein concentrates. Procedures for the manufacture of whey protein product based on known behavior of whey component under defined conditions. Properties that have been exploited commercially for manufacture of whey protein concentrate include molecular size differences by use of ultrafiltration or gel filtration, then insolubility of protein at high temperature, charge characteristics, aggregation by polyphosphates and crystallization of lactose. Now let us discuss these methods one by one. The first method for manufacture of whey protein concentrate is ultrafiltration process. By 1981, ultrafiltration had become the most widely used process for recovery of soluble whey protein concentrate. The development of robust, synthetic and cleanable membranes and the refinement of continuous operation using multi-stage recycle loops and diafiltration have been significant factors contributing to the success of this process. With this process, a highly functional whey protein concentrate is produced for a wide variety of applications. After ultrafiltration, concentrate is heat treated, after which it is cooled and then preheated again for drying. To achieve acceptable powder densities of 0.35 to 0.5 gram per meter cube, it is normally necessary to concentrate in evaporators. The WPC, that is whey protein concentrate 35 to 50% prior to spray drying. Ultrafiltration plant concentrate is evaporated to 25 to 40% solids depending upon the concentrate composition. The evaporated concentrate is then spray dried. The typical inlet drying air temperature is kept from 175 to 190 degrees Celsius. The other method for manufacture of whey protein concentrate is gel filtration process. This process has been used commercially for recovery of whey protein concentrate. The hydrated gel acts as a molecular sieve in that small molecular weight components are able to enter the solvent phase within the gel beads. Protein molecules remain in the solvent phase surrounding the beads. High and low molecular weight fractions then can be recovered. Product of 30 to 80% protein can be manufactured using gel filtration process. The process is expensive to install and operate, and the yield at 65% of proteins in whey is very less. It also is subject to fouling and microbial contamination. Hence, it is no longer used in commercial operations for manufacture of whey protein concentrates. We can manufacture whey protein concentrate by heat precipitation process. Whey proteins may be precipitated with heating of whey at acid or near neutral pH. Acid whey must be heated to at least 90 degrees Celsius and maintained at such temperature for at least 10 minutes to achieve maximum yields. For sweet whey, good yields can be obtained by heating at pH between 6 to 6.5. Although products so derived have higher mineral concentration than those of acid whey, unless pH is adjusted to 4.6 prior to protein removal. The precipitate so formed is firmer and more readily separated than that formed in non-acidified whey. Precipitated protein is removed by settling, washed, re-separated and then dried. In modern plants, high speed centrifuges such as clarifiers and decanters are used for separation purpose. The product is dried using ring, fluid bed dryer, roller dryer or maybe spray dryers. Another method for manufacture of whey protein concentrate is precipitation by complexing agents. This process is also called the cold precipitation process. Numerous complexing agents can be used to recover protein from whey, or these polyphosphates appear to be the only group to be used commercially for this purpose. Long chain polyphosphates precipitate protein from whey at low pH, that is 3.5. Typically potassium polymetaphosphate and sodium hexametaphosphates are used. The precipitates so formed are removed by centrifugation, washed and then subjected to pH alteration and calcium addition to remove the phosphate. Removal of calcium prior to phosphate addition reduces the amount of phosphate required and results in recovery of up to 90% of the original whey proteins. Further modification of this process is also possible. Adsorption method of whey protein concentrate manufacturing. Since whey proteins are amphoteric in nature, solid phase charged adsorption media can be used to remove them from solution under appropriate conditions. Media used for this purpose are regenerated cellulose, titania plus alumina and silica. In case of regenerated cellulose process, whey is first decatenized and then mixed with resin in a stirred tank reactor. After separation of protein resin complex from deproteinated whey, the protein is desorbed at pH 9. Ultrafiltration is used to concentrate the protein solution, which is then spray dried. The dried whey protein concentrate may contain as high as 95% protein. At the end, I would like to conclude that whey, which is a largest byproduct of dairy industry and was considered as nuisance in terms of its disposal into environment, has now turned into a value added product by means of conversion of whey into condensed whey, that is plain condensed whey or sweetened condensed whey, and whey protein concentrate having various protein content, that is ranging from 35 to 95%. Thank you very much.